All right, crew. Welcome to your 5.3 notes on reflections. Yesterday we did shifts and we were introduced to vertex form of a quadratic equation. So we are using the same form today, vertex form. The same h and k are still going strong. H is going to be our x coordinate for the vertex and k is the y coordinate. Just a reminder that H is going to lie and K tells the truth. Okay, now the change for today is A. Our A value can either be positive 1 or A can be negative 1 today. And when our A is negative 1, we are going to get a reflection in the x-axis and the parabola opens down like a frown. So this is when we get this upside down parabola shape. Okay, and we know that we call that a rhox, a reflection over the x-axis. We did that with linear functions. Okay, so what we want to know is, what is this vertex up here? So this is the point -3, 4. And it's telling us that this quadratic function has an a value of -1. So I know that my a is -1. This was my h, this is my k. So we are going to write the equation for this graph in vertex form. So that will be y equals, my a is -1 times x. Okay, so now we have minus -3 squared plus 4. Now, whenever we have minus a negative, that is going to turn to plus. So this right here turns into a positive. Remember that when I plug in that -3, my parabola is shifting left, but it turns into a positive. That's why we say that h lies. So this can be rewritten if you want as y equals negative x plus 3 squared plus 4. And we have that shift to the left and up. And then we also have a reflection in the x-axis because my parabola opens down. Okay. So we have our parent again, just for comparing. We start at the vertex for the parent, which is 0, 0. That's right here. And we have, for graphing, our pattern. If we go right or left 1, then we are going to go up 1. If we go right or left 2, we are going to go up 4. Okay, so from my vertex, I go right 1, then I go up 1. From my vertex, go left 1, I go up 1. Okay, from my vertex, if I go right 2, I go up 4. From my vertex, if I go left 2, I go up 4. Connect my points, and there is my beautiful parent. Okay, so here for my number 2, notice that my a value is -1. So that is going to give me a rhox, a reflection over x. So my parabola is going to open down like a frown. So I'm going to start at my vertex, which is 0, 0. My h and k from my parent are still the same. Okay, but instead of going up, because I'm reflected, I'm going to go down. So if I go right or left 1, I'm going to go down 1. If I go right or left 2, I go down 4. And this is my beautiful reflection in the x-axis, which I totally just botched. Okay, so comparing these side by side, you can really see that this point that was on my parent got reflected to right there. This point that was on my parent got reflected to right there. It is the same distance away on the opposite side of the x-axis. That is what the reflection means. Okay. So we have not had a vertical stretch or compression yet, but today we had our first rocks. Yes. So we have a rocks whenever A is negative. Okay, we did not have a shift. Notice that my vertex is in the exact same spot. So we can always see the shift by looking at the vertex. Okay, so we did not do a shift, we just reflected. Okay, next one. Look at this. I have a negative A value. A is negative. So we have a rocks. Okay, we're going to start at the vertex. Here is my H, here is my K. H lies, so that is 2, 3 for my vertex. 2, 3 is there. Okay, now I'm going to open down with my parabola. So I'm going to use my pattern. If I go left or right, right or left, 1, I am going to go down 1. If I go right or left 2, I am going to go down 4. Okay, so that's how this looks. Like this. This parabola is opening down because it has been reflected in the x-axis. Okay? So this parabola has a lot of transformations because in addition to the rocks, we also had a shift. So we still have not had a stretch or a compression yet, but we have a rocks because we have a negative A value. Okay, and then we also have a shift. We shifted 2 units right and 3 units up. 2 units right and 3 up. And that's my transformations. Oh, I forgot to remind you that the pattern came from the parent function. I think I probably said it, but I did not write it. Okay, now we have to match these functions with their graphs. So wherever we have a negative A value, then we're going to get a rocks. So let's look at these equations. Here on number 1, I have a negative A value, so I will have a rocks. That means my parabola will open down like a frown. Okay, on number 3, I have a negative A value, so I get a rocks. My parabola will open down like a frown. Okay, the next thing that we need to look at are the H's and K's. So for number 1, I have an H because it's in parentheses. So remember that H lies. So this looks like it should be going right, but because it lies, it's going to go left. Okay, next one, we have another H. And H lies. This one goes to the right. Okay, on number 3, we have a K. And K tells the truth, so this is going to go up. And this K is telling me that we go down. We shift down. So let's label our graphs A, B, C, and D so we know which ones we're talking about. And if I'm looking for, on number 1, a rocks with a shift to the left, to me that looks like C. C is 1. Okay, number 2, no rocks. So it's going to open up like a cup. So I'm just looking for a shift to the right. That looks like D for 2. Okay, number 3, we've got a rocks. So opening down and shifted up 1 unit. Ooh, that looks like B. And last but not least, no rocks, but shifted down. That is definitely A. And that's how you can match these. It's not so bad. Okay, so this is not your notes anymore. This is number 5 in the Unit 4 Encore packet. So I would just like to take a moment to review with you how to graph a linear inequality. So the first thing that we need to decide is whether we have a dashed or a shaded boundary. By looking at this symbol, I know that it's going to be dashed. Okay, if I had less than or equal to, then it would be shaded. But we're going to use dashed. Okay, the next thing we need is a table for our x's and y's. And we are going to let them take turns being 0 to find our x and y intercepts. So if my y is 0, then this y goes away, and x has to be 6. Okay, now I'm going to let my x be 0. And x goes away because 0. And then my y would have to be 6. And those are my x and y intercepts that I can use to graph my boundary line, my dashed boundary line for my inequality. So 6, 0 is here. Oops, that's a highlighter. Points. 6, 0 is here. 0, 6 is, whoops, that's -6. Wow, I'm really struggling. Okay, that's this one. And then we said that we were going to use a dashed boundary. So, boop, 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 boop. There we go. Now we just have to decide where we are going to shade. So we need a test point. I'm going to test my favorite test point, 0, 0. And we are going to see if 0, 0 is on the true side or the not true side. So we plug in 0, 0, test 0, 0, and see if it's true. So is 0 plus 0 less than 6? Well, yeah, because 0 is less than 6. So this is on my true side. So this is true. So I am going to shade under my beautiful boundary. Now I'm going to state a point that satisfies the inequality that I graphed. So I can pick any point from the shaded area. So I am going to pick 0, -2, because that's in the shaded area. Oops, 0, -2. 0, -2. But you can pick any point that we just shaded blue.